Guys, welcome yet again to my YouTube channel. Guys, we read this question. Show that the transfer function of circuit is V0s all over VIs is equals to that, where this is equals to R2, that is the ratio R2 all over R1 plus R2 is given by alpha. And here we have tau, which is the time domain, is given by is equals to C. This is C. Open the bracket R1 plus R2. S, that is of Laplace transform, is equals to JW. W represent the frequency. So guys, we come now to solve the question, and the question is right here. Guys, this is our question. So guys, what we do is that we know that we can take that loop. We can call it loop 1. When the loop 1, you have VI is equals to VR1. Current, that is voltage across, total voltage is equals to voltage across R1 plus across C and across R2. That's what I have given here. Then guys, we come to, again, we say across the R is IR1, across the R2 is IR2, plus across the capacitor. In terms of frequency, guys, is I, or in frequency domain is I all over JWC. From there, guys, we can come and now change. We can change this frequency domain to Laplace domain, which now gives us 1 all over SC, whereby JW is equals to S. Guys, we also factor out I. When we factor out I, guys, we now come to this position whereby now we can write the whole of this in terms of SC, that is the common denominator. You do common denominator, you get R1 multiplied by SC, R2 multiplied by SC, now plus 1. From there, guys, we now come and now say V0. For this part, we have V0. V0 is going to go through, the voltage is across C, is also across R2. And that's what I want to show here, across VC plus VR2. We can write that in terms of IR2 is the VC, not really, but I all over JWC is the VC, and VR2 is IR2. That still is in frequency domain, that is JW. Changing that, guys, we can now write in terms of Laplace. And so, guys, we shall now write this I, we have factored out, we get R2 plus 1 over SC. S is JW in Laplace domain. This is equals to I. We can now write this, the whole of this in the same denominator, and it comes to that. Guys, now we are, in fact, we are in Laplace domain, and that's why, guys, I have written S there and S here. That is V0 all over VI. For V0, guys, we have this. We also have I at this point. You had I there. And remember, guys, even this one had an I. And those I's will actually cancel, as you can see for the input. The input has an I there, which is this. And the output has also an I, which is actually the same I, the same current, because the same current is actually a series circuit, and so the current will have cancelled. So having that, guys, we are now going to divide that and that. Dividing that, guys, we are going to have this. This is our solution, or this is our transfer function. But now, guys, we are supposed to replace for R2, R1, and even the capacitor. And this is how we do it. We will come and now say, as we are given the conditions, let me show you the conditions, guys. Here are the conditions that we are told to follow. We have this alpha is equals to R2 all over R1 plus R2. And this tau, which is time constant, is equals to C, then the bracket R1 plus R2. And then S already, that one we have done. So guys, that's what we are going to do. We are going to come, and after we have written that, we divide by R1 all over R2. Dividing that R1 all over R2, guys, now we can replace our figures, whereby for this, the first one we divide by R1 all over R2, the R2 all over R1 and R2 will change to this. That is, we are saying for this R2 all over R1 plus R2, guys, we get this alpha. When we come to the 1, we shall have 1 over R1 plus R2. Now going to this, we divide by R1 all over R2, both will cancel and we are left with SC. For this one, it shall be left like that. From there, guys, we can come and now use this other equation here. Here is the other equation that we are going to use right here. So we are going to replace 1 all over R1 plus R2 with tau all over C, which is the capacitance. By replacing that, guys, this is what we get. So we will have been able to remove 1 all over R1 plus R2 and replaced it with this, that is C all over the tau, time constant. That is, if you seek the reciprocal of this, you get C all over tau, and this is what we have gotten. We can factor out C. Factoring out C, guys, is going to be cancelled, and so therefore, guys, we shall be left with this, whereby now, guys, we can put all these under the same denominator of tau. So we get tau S alpha plus 1 all over tau, and the same case here for denominator. So the taus are going to cancel, and guys, we are now going to be left with that. So guys, thank you for listening to me. Bye.